Bismillah ar-Rahman ar-Rahim. Solving competition number one. Number one, I to the power of 13, you can subtract this 13 minus 12, which is the closest multiple of 4 to get I to the power of 1. And 2, because the power is odd, you can take this negative down. And minus 29 minus 28, which is the closest multiple over 4, to give you negative I. 57, we can minus it from 56, which is the closest multiple over 4, to get 1. And the power, when it is odd, take the negative down. And subtract the 75 from 73, or 72, sorry, to get 3. And that will make to the left side I alone equals to negative I to the power of 3, which can be written again by I to the left and negative bracket negative I. That will make the left side equal to the right side, which be true. In number 4, focus on the last 2 digits, which are 82, which can be subtracted from 80, and that will give you I to the power of 2, which is negative 1. In number 5, the power is even, so you can ignore the negative and focus on the last 2 digits to get I to the power of 24, which is a multiple over 4. So the answer is 1. I to the power of 4n is a multiple over 4. When it is multiplied by the negative, you can ignore the negative. That will return it back as I to the power of 4n, so you can make it I to the power of 4 also, which is gonna be 1, which is a multiple over 4. And here we are ignoring the negative. In 7, if n is an odd integer number, so you are going to solve this power, which is not a multiple of L4, by having I to the power of 2 inside and n outside. Because this n is odd, you need to think about what is inside. I to the power of 2 is negative 1, and the n stays outside. Because it is odd, the negative stays. So the answer is negative. In 8, I to the power of 5n plus 6 equals 1. You can split it to be I to the power of 4n plus n plus 4 plus 2. And that all equals to I to the power of 4. And this I to the power of 4 is the smallest positive integer number, will give you 1. Because we can have 4 or 8 or we can have any number in multiple of 4. So let's try it with the 4. And the 0 also, but the 0 is not a positive integer. Now, anything to the power of 4, I can cancel it. Why? Because it can give you 1 easily, like this. This 4n cancelled and this 4n cancelled, and you can now write what is left, which is I to the power of n plus 2 equals I to the power of 4. I will focus on the powers to have n plus 2 equals 4. Move this to the other side. That will give you 4 minus 2, which is gonna be 2. So the answer is going to be 2. In 9, it is better for you to take I from down to up and change the sign. Similar here. That will make I minus become a plus to the power of 6. Another bracket including I minus I to the power of 6. The first bracket will give you 2I to the power of 6. The second will give you 0 to the power of 6. And anything including 0 will be cancelled. Will cancel everything beside if it is multiplied. So that all will give you 0 for all. So this is the answer. In number 10, because we have 4 consecutive powers like this, so that all will give you 0. So it can't be 1, it is 0, so it is false. In plus, you need to, if you have a multiplication instead or between the i's, if you have multiplication, so you can add powers. So I will add all powers to get I to the power of n plus 1 plus n plus 2 plus n plus 3. And that all will be equals to how much? Let's add all the n. Here we have n, 1 plus n, 2n, 3n, 4n. Let's write it, which is I to the power of 4n. And try to focus on the other one, which is 1, the numbers, which are 1 and 2 and 3. This will give you 6. So we can have plus 6. Now, anything to the power of, we said before, anything to the power of 4n or a multiple of 4, you can ignore it because that will give you 1. And try to focus on I to the power of 6, which is can be subtracted by 4, which is the closest multiple of 4. And that will give you I to the power of 2, which is negative 1. So the answer is true. Now, in question 12, you can simplify each up and down. 1 and minus 1 and minus I, then plus 1, that all divided by 2 minus 2 times negative 1 plus 4 times negative I. And you can cancel now whatever or opposite signs with the same term to get exactly this 1 minus an I. 1 minus I divided by 2, and negative by negative will be positive. Negative by negative will be positive. So you can change it to positive 2 and then minus 4i. You can get 1 minus I up over 4 minus 4i. Take a highest common factor from down like this exactly. Take highest common factor, and that will give you 4 again in a bracket, 1 minus I down, similar to 1 minus I up. That means I can cancel common factors up and down to get 4 over 1 over 4 only. I can get 1 over 4 only. So this will make it true. In question 13, because we have addition or adding, we have to add powers because of the multiplication between the same base. So we are going to add powers. So let's add them. We can have I to the power of 8n plus 2 take care about the signs of the numbers. Positive and negative, take the positive or take the positive side because it is bigger, and subtract. Then you can cancel this 8n because it is a multiple of 4, which can give you 1. And try to focus on I to the power of 2. And that will give you -1 finally, which is false. -1 under the root in question 14 will give you I. And focus on the last 2 digits, which are 32. I can subtract it from 32, which is 33. Here, 33 minus it from 32, which is going to be the multiple or the closest multiple of 4. That will give you 2. You can say that I to the power of 2 equals -1, which is going to be this. 15, you have a cube root of -8, which can give you -2, which is real. Nothing here gonna give you I, because you can have a cube root for something like negative or something negative, exactly like this. So no I here. In question 16, you have negative under a square root, and because it is even root with negative sign, so you are going to have I. So take care. You can have square root of -1 instead of and square root of 4. That will change it to I times 2, which is 2I. In 17, you have a perfect square. You can expand it by squaring the first and multiply it by itself. That will give you I to the power of 4n plus, and multiply the first with the second, keeping this 2 in the middle, which is coming from here. It is 2 times I to the power of 2n times I to the power of -2n, plus I will multiply the last with itself to get I to the power of -4n. Now let's cancel this I to n with I minus 2n. By adding their powers, you can get 0, and that will cancel it to be 1. So what is left is I to the power of 4, which also can be cancelled because it is a multiple of 4. But that will give you 1, and this also. So we can get 1 from the first term, and 2 from the second term, and 1 from the last, and that will give you 4. In 18, you have 5I to the power of -3 minus a 3I to the power of 5n to the power of 4. This power 4 is hard to be expanded, or you can split it to be 2 in the first power and 2 in the second power and split each. Or another way, you can have 5 over like this I to the power of 3n, because when you are moving the powers from up to down, you can change the sign only. Then minus 3I to the power of 5n. I can make this over 1, and I'm still inside the bracket to the power of 4. We can make a cross multiplication by multiplying up and down here by, here up and down by I to the power of 3n. I to the power of 3n. And down also I to the power of 3n. That will give you the same denominator for all, which is I to the power of 3n, and up I will have 5 minus 3i to the power of 8n, all still to the power of 4. This 8n can be cancelled because it is going to be 1. So I will have exactly up 5 minus 3, all divided by I to the power of 3n, which is still under the bracket to the power of 4. You can get after subtracting 2 over I to the power of 3n. This power I can split it to be a power for up and a power for down by the properties of index. You can get by multiplying 2 4 times 16 divided by I to the power of 12n. And this 12n will give you 1 because it is a multiple of 4. So you can say the last answer is 16 over 1, which is 16. And that's it. In 19, one of the values of m that satisfy I to the power of m and I to the power of negative 3n is equal to, where n and m belongs to z. You can think about it as I to the power of m equals 1 over I to the power of 3n. And make this over 1 and make a cross multiplication. Like this, by taking the denominator up and taking the denominator up. That will give you I to the power of m times I to the power of 3n equals 1. You can add powers in multiplication. That will give you I to the power of m plus 3n. Because you have 1, so you can make it as I to the power of 4n to get the value of 1. Or you can have 8n, or you can have a 12n. But he is asking about one of the values which are given in the alternatives to satisfy the answer. So we are going to try for n and cancel the bases and focus on the powers. You can take m plus 3n and equal it by 4n. Move this 3n to the other side and subtract. That will give you m equals 4n minus 3n. And this will be the answer, which is one of the answers that we have inside here or in the alternatives. So the answer is n, and this is the answer. You can also take the answers from here and check them. If you're going to take here 0 and put it instead of it, I to the power of 0 will give you 1, and I, now we don't know how much is ln. We are looking to the value of lm. So I to the power of 0 will give you 1. And you can't get 1 over 3n, which is 1 with the 0 because it's going to be in the denominator. So the best answer is going to be n. And if you're going to take 3n, replace it instead of it. One of them going to be up and one of them going to be down, which can't be equal. If you're going to take negative n, it will have different powers. So the best answer is going to be n. In 20, the greatest negative integer n that satisfies I to the power of 6n. You can choose also from the alternative and replace to be sure which one is going to be the right one. But this way is not really giving you 100% correct answer. So it's better for you to split I to the power of 6n to be 4n times I to the power of 2n minus 2 and I to the power of 4n times I to the power of 1. 1n times I to the power of 1. And you still have I to the power of 4 in the other side, which gonna be satisfied. Now I can make it 4n also. It doesn't matter. Let me now cancel all the common numbers or factors here and there, which is 4n with this one, with this one. I can have finally I to the power of 2n minus 2 I to the power of n plus 1, and that all equals to 1. If you think about this question, you can leave it as it is, I to the power of an n multiplied by I only. And that will make it easier for you to continue like this. Here I will move this one to the other side because I can see that I have a quadratic equation, which including I to the power of 2 here above I to the power of n. So it's a quadratic. 2, and this is going to be 2i multiplied by this together, I to the power of an n, which is similar to this one. Then moving one to the other side to be minus 1 equals to 0. Let me factorize this. That will give you 2 brackets equal to 0. Here, I to the power of n can be written twice. And negative 1 can be written as I times I, because I times I is negative 1. So, according to the signs, they both gonna be negative, negative. And then, this all will give you, to check your answer, you can think about it in this way. Multiply these together, you can get negative 1i times in. You can multiply these together to get negative 1i to the power of n. If you add them, you can get negative 2i to the power of n, which is similar to the middle. Which is similar exactly to the middle. So your factorization is extremely right. You can say that you can write them as I to the power of n minus I, all to the power of 2, which is a perfect square, equal to 0. Then take a square root for both sides to get in minus I equal to 0. Move this I to the other side. And that will be changed to be I to the power of n equals I to the power of 1. Now you can think about which smallest or the greatest negative integer from that you have can give you this power, which is I to the power of 1. I can see that I can have n I to the power of 3, but I'm looking for negatives. So negative 3 negative 3 will give you I, and also you can have I to the power of negative 7 will give you I, and that's it. So which one is going to be the greatest negative integer? So you can choose negative 3, which can give you easily this one. Thank you for everything. If you have any question, you can ask. Good luck.